Hey, everybody. This is Josh Mancy with the Corn Belt Newsletter, farm realtor from North Central Iowa. I'm super pumped today. I have what I consider the preeminent ag meteorologist, Eric Snodgrass, joining us today. And Eric, I'm going to turn it over to you. You want to give a little introduction? I don't know how much introduction you need, but little introduction, and then I'm going to turn the reins over to you, and we'll have a dialogue and talk all things weather, especially here the next couple months, which are so vital for the growing season.
Yeah, I appreciate that. It's kind of funny you bring that up because this has happened like multiple times with my 12-year-old. So my son, he asked me again, like, tell me again, Dad, like, what is it that you do? And I'm like, well, I forecast the weather for farmers and for the ag industry. And he always goes like, and they care what you have to say because he doesn't care what I have to say. And I was like, well, Graham, yeah, I kind of, it's kind of fun. But no, I work for Nutrien. I'm a senior science fellow at Nutrien, and trying to understand weather and its impacts on agriculture is just a lifelong problem. I'm trying to find a solution to, and I tell you what, it's a daily battle. You wake up every day to a new problem. It's just like in farming. There's something we do in farming, right? That if you ask me, is unique to this industry, and every single thing that we do is about the future value of something. So it's weird. It's not you're investing your time and effort and money into an asset that you're unsure of its future value, right? And that's all we do. We just live in the future, and you're trying to market it. You're trying to make sure it stays healthy, and then you've got this massive source of what we just generically call abiotic stress, which is environmental stress, and it takes everything you just paid for in that bag of seed and cuts it by 75%. It's like, see if you can try to get yield out of this. And so I'm the guy that either makes people really happy or they're really angry at me all the time. And so, anyways, that's my introduction. Or as my son would say, like chubby white dad who forecasts weather in basement. That's the other one I typically go by. So,
We'll
yeah,
take that
great
one
to
too.
do this. Yeah, all right.
Well, Eric, why don't you pull up your wonderful computer slides?
Yeah, let's see if we can get this going here. I want to show you. Yeah, good. This is one I wanted to kind of start with you on. Let's just talk through where we've been. How about that? And then see if this sparks any questions out of you, and then and we can maybe make a story out of this. This actually comes from Iowa. I love this website. This is Iowa State. They have a brilliant scientist there. His last name is Hertz. He works at Iowa State, and he has compiled this incredible history of weather data. So what I did here is I went back for all of April and all of May and the first 2 days of June, and we just made a rank map, right? So you've got 133 years in the data set. If you're close to one, it's wettest. If you're close to 133, it's driest. Now I'm going to tell you something, okay? Me being from Illinois, you being from Iowa, there's a lot of people that think right here on I-80, this is the garden spot. And even with that, it's been dry, right? We've technically been dry. In fact, earlier this morning, so I'm in Champaign, right about there. I went outside and was just working at the bench outside the office. And after about 5 minutes, everything was covered in dust. So we've had just in time rains that have kind of inched this crop along, and we're doing pretty good. But you know the issue in these areas is that we still have sitting under our soil here some dryness. I mean, or excuse me, out of that topsoil. If you look down there at 100 centimeters using NASA's data, you find that that same corridor still has some remnants of fall's drought. And so we've always been worried, is this going to be the spot that come midsummer doesn't have what it takes? But then again, how many summers in the last 50 have we gotten just in time rains? I mean, we're literally, I wonder if I can pull this up for you real fast. Let me open up another window here. I'm going to go to just weather.gov. I was looking at this the other day. I'm going to come in here, just drill into Iowa. You're up by Mason City. Okay, so that's going to be the Des Moines Forecasting Office. By the way, you're under an air quality alert because of the wildfires in Canada right now. But
Nice.
if I click on past weather, oh, don't tell me their website's down. Let's see. This is a good site. They may be updating it right now. Mason City, Iowa. Now look at this. Let's do accumulation graphs. And I'm going to go back to 2020. And I want to show you something. Oh, you got to be kidding me. Their site must, oh, there it goes. Good, good, good. Look at this. Since 2020, that smooth running line on top is your average precipitation. And the line below it's where you've been. So what's crazy about your area is that where you currently are sitting, you're like 16, 17 inches off over the last 5 years in total, which means you're almost what, half a year's worth of rainfall behind, which means in many of these years, and by the way, that does include, don't forget, the epic rainfall you had last spring. When I say epic, I
Right.
mean flooding,
Yes.
just tremendous rain. Before that, though, you were off by what, 30, maybe 30 inches in total. And so what's interesting is all that is still sitting in these subsurface soil moisture deficits. And you go straight south of there, and they have had so much rain. It's like I've been calling it a brown ocean. I mean, we've had so much flooding, sorry, down in this area that we're getting evaporative processes off of the mid south and southern plains. That's just like coming off the Gulf, and it's just been supplying that moisture. And this is where this kind of brings us all to a head. You go back into April, May, and now the beginning of June, and see just how wet we've been in this corridor. And the issue here has been that if you wanted to produce massive widespread drought in the Corn Belt, you can't do it if it's already wet right here. Because all summer long, even if this starts to dry out, all summer long, moisture is going to try to go from here up into, eventually into your neck of the woods. And if there's already enough moisture in the soil here in vegetation, it won't steal it from the Gulf. Every major drought episode, 12, 88, you go back and look at all of them. They were in spring really dry. So what does that mean? That means as we get into the summer time frame, and I'm thinking hard about the I states here and Nebraska, and let's just do this. I'm thinking hard about that corridor. That's our big corridor, right?
Yep.
To have big season-wide drought went from a 60% risk preseason. Okay, that's what it was before we started spring. But because of all this, we're now down to about 45% risk. That is below 50-50. So what is that going to mean? That's going to mean that if we have drought in that area, it's going to be of the flash drought variety. But before I go any further, I want to make this point. Yeah, look how cool it's been since the end of May, right? We're behind in the Eastern Corn Belt, Great Lakes into the Northeast. In fact, you go talk to guys in Iowa right now, or Ohio, excuse me, they're angry. Like, what are you talking about? This crop is 90% done. Like, we are so far behind, and they have been because of just how cool and wet it's been in this area. I would just say this, there's another problem brewing here. We're going to have prevented plant down in the Delta. We're going to have problems when they replanted, they got mudded in. They're going to have problems with spring application because it was way too windy at times and too wet, which means that the odds of this crop, in my opinion, just right now, of actually getting to that 181 on corn that the USDA is talking about, I don't know how that's going to happen unless it is just perfect in this area for the next 4 months. I mean, it's got to be absolutely pristine perfect, and that'll make up for the deficits all around it. So, some preliminary back of the envelope calculations, we're looking something closer to maybe a 177 right now. And the sad part is, Josh, is that's not enough. I don't think that's enough if you look at the balance sheet for based purely on supply and demand. And this is information coming from my friends that are really good at economics. Okay. I just think
Right.
it's enough to get $5 corn out of that, which is not the right story. So what's funny is I've been talking to so many growers in the last 2 weeks, and they're all praying for a disaster, and they just don't want it where they are. They're like, come on, just
Right.
knock this thing
Right.
sideways, make it problematic. And I just don't have, you know, I can tell you where the problems are going to be. It's right here. Take a look at this precip forecast. We're getting, you got a decent chance of grabbing another half inch to an inch of rain across Iowa. Same thing for Illinois, but we're going to flood out Kansas, Missouri, Oklahoma. They're going to get more rain down here, and its place has been completely saturated. So I just I look at all of this and I'm just wondering, is the response going to be appropriate to this adverse weather? And do the people that trade the markets just see green, you know what I mean, and don't see problems everywhere? That's what I'm thinking about right now. What are you thinking about?
Well, you make an interesting point with the problems they've been having in the eastern part of the Corn Belt there in Ohio.
Yeah.
Um, the other thing you were mentioning, I think is interesting, and maybe you want to go back to that, is the ranks on that, the stuff on the down there in the Kentucky area,
Yeah.
the
Yeah.
Delta in general. Are you saying that because they've got so much moisture there, that that knocks our chances of drought back, and how does that work exactly?
So let's do
That'd
this.
be
Okay. I'm going to go to that website so people can actually see how it works. It's a great website. There it is, Iowa State. I'm going to do this. We're going to look at, uh, well, you know what? Here's easier. Okay, let's go to the U.S. Climate Division's website. There we go. Now
Everybody,
watch
this is why
this.
we like Eric so much. He has all the fun tools that we don't even
Yeah.
exist.
So if we just do April and May, and let's put in some nasty years, 1988, 2012, 1983, 19 not oh 08, 1980. Let's put in there 1991. What was another bad year? Did I put 88, 83, 12, 1976? Okay. And I don't know, let's set some ranges on this so that it actually looks okay. 0.25, that should be good. Now what I'm going to do is, let's see, more of these years are in that earlier time frame. Okay, so I'm going to make you a composite map. Whoops, I selected too many levels to do it over. Let's make this 0.5. That'll work now. There we go. This is what April and May looked like during these bad years. So we were super wet down here, but this whole area was already dry by April and May. So that means there was nothing in here to recycle, to just keep using as we got farther into the growing season. And by the way, just so you understand, I set these thresholds to be 5 inches off. So I mean, if you're 5 inches off in April and May combined, you're at like 10 to 20% of normal rainfall. So this becomes an issue with already having drought problems in place. So when you started to blow the wind up through here, or if it came out of the west, guess what it was blowing over? Really dry conditions. So you just didn't add anything to it. And in fact, this part of the atmosphere was stealing any Gulf moisture that came out from the south in those really rough years. And so what happens is you go from April and May looking like that to June through August, looking like this.
Oh my gosh.
So just boom, it's gone. You have nothing to return the moisture. And so what happens in this situation is when you get dry in an area, instead of some of the sun's energy, which hits the vegetation, hits the ground, and like maybe up to half of it gets used to evaporate the water in the vegetation, okay, you've got 100% just going into making it hot. Well, you make it hot, the hotter the air becomes, the harder it is to saturate. The harder it is to saturate, the less chances are of clouds and precipitation. So guess what? More of the sun's energy comes in and heats it up more. So this dome builds of heat. And guess the jet stream just goes right over the top of it and leaves a large ridge of high pressure there. And we were legitimately worried about that for this year, mainly because of some signals we had in the ocean temperatures. I still have these up here. It's been cold right here. And if you look historically at all those years, in fact, I'll just do this. Might as well. Let's just do this. Let's do, this is going to come from composites. Let's go there. Composite. So let's put in those years again. What did I say? 1988, 2012, 1980, 1983, 1976. I think I threw in 1991. And
Yep.
you say, just show me what was going on in June through August in those ocean temperatures. Let's go find ocean. There it is. Let's do that. I got to blow this up a little bit. I'm going to make it so you can see it real clearly. I tell you, let's do small here. -1 to 1. That'll be good because that's a big range in ocean temperatures. See if it goes. There it goes. Look at that. I mean, we were just cold in the water temperatures here, really cold in these water temperatures. So you say, well, what does that do? What that does is that takes the jet stream during that time frame. Let's just go up there and have a look at it. Okay. Get rid of these because we don't need them anymore. And what it does to the jet stream, let's see, 500 millibar height. All right. Is it gives us this. There it is. You get a high pressure cell there. You get one high pressure cell here. And there's the Bermuda high. That's not Bermuda, that's Iceland. This thing should be there. And it's just gone. It's waved. So that leaves this big area of high pressure. So the jet goes like this. And it just stays. So what you now have is flow going around in this direction. And if it goes around in that direction, guess what it's not doing? It's not tapping into Gulf moisture. You need to have high pressure here so the flow goes around it like that. And guess what it does? It just opens up the Gulf. And so these are the disastrous years when this occurs. And the preceding indicators, cold water all along the ocean, the ocean surfaces that lead, the west coast of North America that leads us to this. So back to the whole point of the story. We have got cold water here. That's one signal. There's a fading and dying La Nina. We're INSO neutral now. That'd be a second signal. The third one is supposed to be right there. And over the next 40 days, if this goes over cold, drought risk in our states goes up. But it can't go up to the magnitude of those banner years because it's been too wet to our south, which means we're going to be into a situation where we're going to be worried about flash drought and flash heat in summer if you're going to worry about that side of the equation. And I would tell you that the ocean temperatures are leaning more toward that risk than the risk of being wet. You say, well, what would be the wet risk? Well, the wet risk would be if
Right.
all this warm water was way over here up against the Gulf, the West Coast, excuse me. If all of this was just really warm, it wasn't here, it was over there. Oh, we would be talking about, tremendous heat in the Western United States and then ridge running storms that come right over the top of this and just kind of bow down through the country like that and save the day. So I think right now the risk is more on the midsummer flash drought problems than it is the other way because of this cold water. But I don't think, and you probably know more about this than I do, but if you look at what's happened since 2012 in the Corn Belt, right? What's the biggest change? We have gone through this tremendous evolution in seed technology that has made crops that if you would have put them in weather scenarios 10 years ago would have yielded entirely different than they are now because we've basically engineered the seed to create a plant that's just so much more resistant to these things. And so I got asked, this was last winter, somebody asked me like, hey, do you think you could ever have another 2012 yield loss again? I'm like, what, we're 25 to 30% off trend? And they're like, yeah. And I said, it would take something. It's not just drought. You'd have to do something where you late frosted it, and then you didn't just 2012 it, like you baked it like 1936 or 39, and then sandblasted it late in the summer, and then I put a hurricane on it in September. Like you'd have to just do everything but
Perfect
wrong.
storm, right?
Yeah, and that just doesn't happen. So I don't know. I don't know if we're capable of dropping yield that far off of trend anymore, given what we built in terms of resiliency with the quality of the seed and the equipment and our agricultural know-how. I mean, we're really good at what we do, to be honest with you. That's important to know.
So Eric, it seemed like, the drought talk was what everybody was talking about in the winter months.
Yep.
You're saying the stuff that
Myself
happened,
included.
no, I believe
Yeah.
me, that was what
Yeah.
the talk, believe me, that was what the talk of the town was. It was like, hey, Snodgrass is predicting a drought this summer.
Yeah.
And so here's my question on that, not to rehash that out, but it certainly seems what you're saying is the moisture that has gone in the Delta region in the South has put a buffer on that. That's what's put the buffer.
Yes. Yeah. It's put a buff, but that's the only way to think about it because you go talk to anybody in the Delta. I mean, I just was on a call with my friend down in Nashville, and he's like, Eric, I've lived down here long enough to know that we could be in the garage building an ark because of the flooding, and next week tell you that we don't have enough rain. He's like, we're always a week away from drought. And we've seen it in the Mid-South before that come July and August, they're baking and there's no moisture. The storms are very regional and they've got problems. And so we can't rule out the fact that there could be it's rare, but there can be a pattern flip or reversal in that area. Now, that's going to take just too much time. That's my point. If we were going to have big drought, it would have to have already started and it'd have to be going through the end of June, which is why we're just now worried about the flash drought. But I'll be honest with you, when we had that narrative out on drought, I actually couldn't find another meteorologist or a model that wasn't in agreement. So when I was going around talking at all these events, I'm like, look, I'm going to tell you two things at every meeting I went to. One, do I think there's risk of summer drought? Yes. Is it 60%? Yes. That means that 4 in 10 times I'm going to be wrong. Just be clear. I said, secondly, if I really knew what summer was going to do, I'm not telling you about it, right? I don't tell anybody. I tell my broker, and then I retire.
Right.
So it's just a reminder that we're trying to predict the future of a nonlinear chaotic fluid called the atmosphere. But let me show you something. We've been looking at this map here for a while. This is not that one. Look at this. That is still the Climate Prediction Center's forecast for July, August, and September. Right now in Missouri, where it is flooding, they're predicting a major dryness factor going forward into July, August, and September. And it goes right through Mason City, man, where you are, and up into almost Minneapolis, St. Paul. And if that means that others are still seeing evidence that something like this can occur, and it's not just them. We're going to get this later this week. This will update on the 5th. But if we go over here and look at the European extended forecast, this is their long range one. I'll just go to precipitation here. We'll look at a seasonal anomaly. Let's do that. Take a look at this. That is the July, August, September precipitation anomaly. So again, they're wetter here, but they've got a region in there that's drier. And, there's more support, like in MME, the National Multi-Model Ensemble. Let's look at their US precipitation rate for July, August, September. See, they still have. So when you look at that, and I mean, we can even go one other place. I'm going to take you to a different browser because I can't seem to get this to pull up on Chrome. But if we go to the IRI multi-model seasonal forecast, it shows it better in Safari. Look at this. This is July, August, September. Again, they've got Western Corn Belt drought. They've got Montana, Idaho drought, and they've got Black Sea drought.
Yep, I see that.
So you're sitting there going, okay, Eric just showed me 3 different forecast models. They're all independently run. One's in Europe, one's at Columbia University. The other 8, which are put into that one map I showed you from the NMME, those are run all over North America. And they all show something similar. And then you say, well, the Climate Prediction Center, where did I put that one? Is like this. And you say, well, there's still a problem where the ocean temperatures are cool, and we've got this still on the so we've not removed it from the narrative, but you can't argue with this map right there. We only have 23% of our corn acres in drought right now. And as you kind of look at this closely, these guys have the opportunity to irrigate it, right? I mean, they did it in April when it was bone dry. I mean, not everybody here has irrigation, but they do. But most of Iowa's out of drought. Most of Illinois is out of drought. And while this is very productive ground in northern Illinois and northern Indiana, don't forget there's also a major city in there too that takes up a lot of that ground. And I went over to my grandma's house. She's over here in Western Illinois. Fine. There's no problem with the crop over there. I just saw it. So, you got to look at this and ask the right questions, which is and you just did it. What have we de-risked the situation with all this rainfall that came in here? If you are an I-state farmer or surrounding state, yeah, you have. But it doesn't mean we're out of the woods yet. And look at 23, right? Bone dry spring, stormed all summer. Then you go to 2024, record wet where you are, okay? Well, how did you finish 2024? Absolutely bone dry.
It was,
And
Eric, it was crazy. It was all of a sudden we've got more moisture than we can handle, and all of a sudden the faucet shut off. And
yeah,
here's a question for you on that, not to go to a completely different subject, but what, like last spring, early summer, what happened? Like all of a sudden the heavens opened.
oh yeah. Let me show you it, by the way. So I went to Mason City. So this is what happened last year. So if that's your average rate of precipitation right there, you were at one point in late July, you were at 33, 34 inches when average is like 24. So I mean, you were 10 inches above normal at that point, and places around you were considerably wetter. And then look, you flatlined right there. I mean, nothing. So you went from one extreme to the next that quick. Now, what happened last spring was that, I'll just pick a map and draw on it just to do something here. Okay, this is another ocean temperature map. Last spring, the Bermuda High was right there. And the flow just came around it and went straight up to your part of Iowa. And we actually built in higher pressure at times here. So the flow came over the top like that, and it just all met right here. And as you were just the epicenter of squeeze between 2 high pressure cells. And then when we got into fall, just to draw on the same map, the Bermuda High went from here all the way over to Africa. When it left, that allowed hurricanes like Helene to come up and sneak in there. Well, we had nothing, no flow, nothing at all. And it was just a complete mismatch and movement of the Bermuda High. So if you would like to know what I'm watching like every day, I'll take you to one of my favorite websites, earth.millschool.net.
We want to know what Eric is looking at on a daily basis here.
Yes. So this is what I'm looking at on a daily basis. Okay. This, the thing, okay, is that, I don't know, let's skip ahead a couple of days so it looks a little bit more. Yeah, there you go. Look at that. Okay. This is all a part of the Bermuda high pressure system. Okay. And it's right there, but it's got an extension on its south side. So look, see how this is coming through the Caribbean, into the Gulf, into the central US? If you took that thing and it slid way up here, all of that flow that comes around like that goes with it. And so if you take that high pressure cell and it just wafts on up here, which it does, some years it just does that, the atmosphere just gets out of whack. There's no open Gulf moisture transport. So it just says, oh, let's get hot and dry right there. And guess who loves it? The Southeast loves it and the West Coast loves it. When we are baking, they're having their best growing seasons ever.
Interesting.
Yeah. That's it, man. That is it in a nutshell. Watch that Bermuda high. But every time, let's bring it over to more US centered here. Every time the Bermuda high is somewhere in there and the Pacific high is somewhere in here, it's kind of like they've squeezed in on North America. The flow comes right up the middle nice and strong, and that flow is saturated. And so we get storms. And that's what it's doing now. So if you want to see a problem, what we'll be doing is we'll be looking at weather models. Let's go back to this one. I'll show you the weeklies. This is the one way I like to look at it. We'll do global equatorial view. And here it is. This is from now to July the 2nd. These contours represent where the high pressure is. So there's a high here, and there's another high there. Those are the two we're watching, okay? Now, the color shading tells you where they're higher or lower than normal. So if the high is supposed to be there right now, the Pacific high is a little shifted north. I need it. Well, let me rephrase that. If you would like a drought, you need it to go way over here. And right now, the Bermuda high is just a little shifted north, but not far enough. If you were looking for a big drought, it'd have to go way over there. And we're just wondering if and when it's going to do that. And even if you look out there all the way to mid-July, it tried. See, it tried to move over there a little bit, and it tried to move over there a little bit. I'm just looking at those epicenters of warmer colors. So if you zip back to the United States and just say, show me the 30-day precip totals from June 18 to July 18, see what the model's doing? It's finding that Mississippi River and making it wet east of it and dry west of it. So if the high keeps going, then this expands in dryness. See how that works? But as it stands, that's right, it pulls it. Now, trust me, this is the model being consistent with itself. This model did not predict all of the Mid-South rains and Southern Plain rains back in March. So we take all these models with a grain of salt, but that's where the risk still sits on the table. And while we have changed our narrative, which by the way is good forecasting, you should always be just prepared to change the narrative when evidence overturns it. I know people get mad at that, like, well, you said drought back in February. I'm like, well, yeah, I said it February, but that was what the clues were in February. Right. And we knew that it would change. But I always tell everybody, my most important forecast is probably on June, I'm just going to write it, 17th through the 23rd. And why that's so important on June 17th to 23rd is I'll know if that Bermuda high is here or if it's way over there. And if it's moved in about 3 weeks from now, then we do have a narrative for a drought. If it has not, then all you're going to hear me talk about is pressure on the crop from fungus. You're going to talk about steam in a crop out with heat and too much moisture. So there's always the flip side of this, right? It's never just like, how often do we get 2009s, right? Where it's just, oh, it's cool. The rain was regular and we have huge yields. Like that is a rare thing too. But those years do happen as well.
So Eric, explain to everybody the Bermuda high, and that can that sit in that same spot, and the chances of it moving away, or if there's a chance actually it moves to would it be moving to the west? And if it moved to the west, then from what I'm gathering, that would lead to more moisture for us, would it not?
Major flooding, yes. Let's go back out and show you this again. So this is kind of neat. Not this map, but this one. We'll do 30-day pressure. There you are. So flanking North America, we have these subtropical highs everywhere, by the way. They're right about here, about 30 degrees north, something around there. This subtropical high is why there's a desert in the Sahara. And that, so it's over here. There's a desert in China. And then down here, we have a desert in Australia, and there's actually a high desert right here, but the mountains mess with that. So this is our subtropical high desert area around the planet. North America, the reason why we don't have a major desert here is because we have a mountain chain and we have no mountains that block any sort of moisture coming from the Gulf, right? So there's no mountain chain that's in the Mississippi or Missouri Valley. So what ends up happening for us is these mountains act as a little bit of a disturbance in the way the jet stream flows over the top of them. And it creates little low pressure systems and they just draw moisture into this area. Okay. And on top of that, there's soil that has water holding capacity. So we don't have sand, we've got dirt. Okay. Those high pressure cells are there mainly because of geography. If the United States wasn't here, this would all be one big subtropical belt of high pressure. So here's what happens every year. We have to just figure out where they're going to be. Most years in the last 40, the Pacific high has shifted here over toward Washington and Oregon. So the flow comes over the top and we get ridge riders all summer. And that's why since 1980, you could go 80, 83, 88, and 12. So just 4 times in 45 years have we had expansive drought problems. It's rare where we are. Whereas out west, it's like every year. In fact, since we're talking about it, let me show you the influence of these Bermuda highs. Let's go to Climate at a Glance. This is one of my favorite websites. I'm going to go to region. We'll do regional time series. And I don't know, I'll leave it in the Ohio Valley first. Let's do the 7 months ending in October. We'll call that the growing season. Let's put a trend on this from, I don't know, I'll do my lifetime. I was born 1980. We'll just use that one. And here we go. Nope, I don't want temperatures. I want precip. There we go. Look at that. Since 1980, we've technically been on an upward trend there to the tune of about 3/4 of an inch a decade. So if you multiply that by 5, I mean, we're talking about 3.5, 4 inches of extra rainfall. Now, how about temperatures? Let's do maximum temperatures. Okay, they're coming up, but where are they coming up from? Coming down from the 1930s. See that? So we were coming up in the 30s and we came back down. Now we're making a slow recovery in these maximum temperatures, but your real biggest change there is going to be your minimum temperatures. That's a more robust upward trend. But you want to know why it's going up? Oh, sorry, I didn't mean to do that. It's going up in that area because of extra moisture in the atmosphere. Now let's flip this over to, let's just go to the west and let's do max temperature, or just do average temperature. And let's just park it right in the middle of summer. Okay, that's easier. This is their temperature trend in the west. I mean, holy smokes.
Wow.
That's 5 degrees of warming that's happened over 45 years. So that warming builds ridges. Those ridges live west. They don't live here. And that's why we're getting wetter at the expense of them getting drier. And we're analyzing and trying to see what these patterns all mean. So the high pressure cells influence this. This is what they do. And if we went back and tried this again, let's go to composite. Let's try this one more time. How about we go to June through August? And I'm going to look at years from, I don't know, 2000 to 2024. And I want to look at those ridges. Let's look at this. Okay, let's do anomalies. Okay, that should be good enough. Look at that. So the trend since 2000 to 2024 is more summers producing ridges there. So the flow goes over it and cascades into thunderstorms here. That has been what, so we are wondering if this year breaks that trend temporarily by bringing that high way over there. Is why these subtropical highs are so important. They're everything. Everybody likes to watch the big spinny bits, the big low pressure systems. Those things are boring. Who cares? They all, I mean, I hate to say it, but like if we go to COD and you look out here, most people are like, oh man, look, there's some sort of a tropical thing going on here. There's smoke. And they're like, look at the storms. I don't care about any of this. This is all an afterthought to the fact that high pressure built in here and high pressure is built in there. And it's just where the atmosphere is getting squeezed. So if you want to, it's like taking a picture and looking at the negative. You want to look at the open space to determine where the space is going to close in. So I always want to know where those high pressure cells are going to go. And just to be clear, I could talk confidently about it in the past all day long. I could not accurately tell you right now if the Bermuda high is going to end up near Iceland or or Greenland or maybe over by Ireland. But I'll tell you, if it does, you've got risk building into the picture.
So Eric, the Bermuda High on the eastern side of the United States, and what do you call the high pressure
Pacific
system?
High.
What's it
Yeah,
called?
it's called
Pacific
the
High.
Pacific High. Yeah.
So those are your two basic fundamentals, is what you're saying, and
Yes.
how they're moving.
Yep. That's first principles of atmospheric sciences. We always like to look at all the little no. Step back and say, how is the atmosphere breathing? Where is it taking deep in and deep out? The out is big storms. The in is big high pressure. Find it and just see if it's shifting. And if it starts shifting around, then you've got something to talk about. If it squeezes in on the US, we're going to talk about nonstop wet summers. If they diverge from the US, we fill in the void with high pressure. That's it. That's it in a nutshell. I make it sound so easy, but my goodness, we can't predict it. We tend to observe it in real time.
Well, that was going to be my next question. Like, this is probably not a great question, but is there anything that influences? I mean, what is the main influence of
Yes.
that
Oh,
influences those
yes.
two?
Okay. This is where we get to our deepest nerd level today. Okay.
Let's rock and roll.
GSDM. All right. So I'm working on creating my own version of this. And this is, I told you to look for the high pressure cells. I also look at this every day. All right.
We're getting down to everybody. We're getting to Eric Snodgrass's fundamentals here. This is
Yes. This is it. Okay. If so, despite what some NBA superstars and movie stars may tell you, Earth is in fact round. Okay, we can do a whole podcast by that, but okay, so it's round and it rotates. So we rotate to the east. That's why the sun rises. Okay. So the Earth is rotating as a solid object, and on top of it is this. It technically behaves as a fluid. It's the atmosphere, but fluid dynamics applies to it. What is constantly being observed is the Earth's rotation measured against the atmosphere's rotation. Okay, so just imagine, like you covered a ball in water and you spun it. Well, the water is going to do things on top of it. Okay, when the Earth's atmosphere in certain parts has got more momentum than the Earth rotating beneath it, it spins up into lows, lots of them, and we get frequent thunderstorms, frequent wintertime. We just get frequent rainfall and precip. Now, if the Earth spins, but the atmosphere is slower, if there's less momentum, it doesn't do that. It tends to get these really long waves and big high pressure cells building up. All right, look, back in late March through the month of April into May, that right there, those blue greens or whatever, that was a time period where right around our latitude range, let's call it 25 to 45 north, in the Northern Hemisphere, it lost momentum. And I'm going to tell you something. I'm going to show you how close we were to a disaster, okay? Let's do this again. I'm going to go to day. We'll do this again. We'll go back up to those same heights. I'll just pick May just for quickness here. Let's do May 1st to May 31st. There we go. 2025 anomalies 200. And I just want the North America. I don't want all of it. There it is. Now take look, here we go. There it is, look. Now, these blues, that's trough. These reds, ridges. It's not temperature. This is well, it's technically temperature, but don't think of it that way. It's just temperature in the upper atmosphere. So the jet stream should do this, goes right in between it. Now, that ridge, that's exactly where the fires are right now. Okay? This is the the Pacific High. It was north and a little bit west of Hawaii. If it kept going, well, that's another problem. This is what I missed. We thought the atmosphere is going to lose this momentum, and it loses it when there's more high pressure. 1, 2, 3. But that one is your Bermuda High. And not until April did I see it. We started to get these lows that started here, and they were completely cut off from the main flow. The main flow is way up there. So they just went really slow like that. So this whole area dropped in pressure, dropped in temperature, and right down here got really, really, really wet. Why? The Bermuda High was pumping moisture into it just like that. This is what I didn't see back in February in March when I was predicting April and May. Oh, we thought about that. We thought about these troughs and this ridge way over here. I thought we had that. Just didn't see this. So when it started, we're like, wait, okay, it's gonna go, it's gonna go, it's gonna go. And this is what's unique about it. All that whole time period, the momentum was gone. It was north, but those little cutoff lows moved very slowly in this, and they will only do that in spring. So here's your secret sauce, if you will. If this shows up again, so this goes up to today, right? There's June 1st, 2nd, 3rd. If it starts again here and we get another big stripe of green going in that direction as this map, continues to evolve in time, then we're going to have major drought. Because what's going on is the flow stopped, the high pressure builds, and they just wander off. They don't have any reason to stay there. They'll just wander off. And they like to move north and away from the continent. So I'll be watching for Earth's momentum to slow down in midsummer. If it doesn't, ridge riding thunderstorms 3 or 4 times a week, crops huge. That's all I know. I mean, I don't know. I can't take it down any farther. But here's the thing about all of this. We could know this inside and out. Like, I'm sure you understand market fundamentals, right? I mean, you can understand a supply demand model, right? You own a business, you understand your finances. Try to predict them, right? There's too many little things that could change all of it. And if they happen at the perfect time, doesn't matter. You know what I mean? I could predict record hot summer, but if for 1 week, July 4th through the, I don't know, let's do 10 days, July 4th through the 14th, it's cool and stormy, crops probably going to mostly be there. So there it is. That is the trick in all of this, is the prediction. And it's hard.
Well, you have so many different variables that you're having to, and it's changing all the time. Now,
It is.
I mean, I think that's what everybody needs to understand too. The other thing, so you talked about flash drought.
Yeah.
Okay, so what does that look like
Sure.
on the weather
Let's
model?
do something here.
Let's look at that, because I think that's an important point. Because it's like we could still, even if things actually go our way, we could still have a potential issue.
Yeah, I'm working on a new set of tools, by the way, and I hope I hope we're going to get these put into our whole digital ecosystem at Nutrient pretty soon. But like, I don't know, I'm going to go back to Mason City. I'm just going to drop a pin in there and look at it. I wonder if your location, so forgive me, I'm going to scroll a little bit. This is where I keep all my nerdy weather data. There we go. This is what I want to look at. Year to date precipitation minus evaporation. Okay. When we get into summer and the temperatures are up, if you miss the thunderstorms, if they don't hit your county, what happens is that you're unable to offset the daily fact that you will lose in summer heat 0.2 of an inch of moisture every day. Like, that's just how much can evaporate. And so over time, it just keeps adding up when you're not getting rainfall. So if you look from May 1 to May 19th, your precipitation minus evaporation was going negative. And you say, well, what was going on there? Well, from May 1 to May 19th, you flatlined on precip. There's nothing. What I'm worried about is you can't afford to have a plateau like this a month from now. Excuse me. That's the wrong time of year. Unless you have a completely full profile of moisture in the soil, you can only handle one of these things for about 10 to 12 days in July. You've got to have some sort of rain.
Well, I was going to say, my rain gauge today, we had a really nice system that came through. It's over 2 inches of rain in the rain gauge today. I mean, I think sitting right now, we should be sitting fairly good.
Yeah, you should. And I only predicted for today 0.91. So you outpaced.
And maybe we're a little west. Algona's was a little west of Mason City, but Mason City had to probably get as much as we did too.
I'm somewhere north of Mason City. I had 0.96 inches there. Excuse me, 0.96 for the last 24 hours. So yeah, that's what it is. And so here, I know a better place to go. Do you remember earlier in the year, parts of Nebraska were really dry? Let's go to Kearney. That's a good spot. Now, let this reset. There it goes. They just got an inch of rain too there. I'm gonna scroll all the way back down to the bottom. There it is. Look at that. You see Carney's problem? Even with the little bits of rain they've got, they've not been enough to pull them back up. So they're technically 10 inches in the hole since the beginning of the year, even though if you look at their total cumulative precip, they're only off, by about, what is that? That's about 10 inches to four. That's only a 6-inch deficit. But you see, this is just adding up rainfall. This does not account for the fact that the atmosphere evaporates some out. So this is why they're so vulnerable right now. And if they can't irrigate a crop, they are very susceptible to a flash drought problem, especially if the temperatures crank. And I don't think the temperatures are expected to go up pretty high there anytime soon. Let's go look at it real quick. Sorry for all this. Actually, they are. They're making a recovery through early next week, back up at around 80. Look at this. Some of the models have them well over 90 by the time we get to next Friday, Saturday, Sunday. That's the 13, 14, 15, 16. So that is what a flash drought scenario is. So what you're doing is you're going to take that crop and you're going to zap out the water from its vegetation. So what is it going to do? It's going to go looking for water to pull up through its system. You're then going to pull it out of the top 4 to 5 inches of soil very rapidly because the plant, in order to live, must evaporate water. Transpiration is a part of the whole ability for it to, basically, pull in CO2 and make plant matter, right? So then what does the plant do? Well, under that stress, it rolls everything up, leaves go straight up. It does that to minimize area with the sun. This is okay. When the plant curls up, it's okay. That's a defensive posture. But then if you don't give it water and keep it too hot at night, it never lets go. So now all of this sugar that we want to go into that seed is being used just to hold itself upright, to prevent itself from dying. And the plant, I know these corn crops love to reproduce. They're like, it's like prom night for them permanently, right? But they will also go into self-preservation mode and say, no, I got to stay alive, and therefore we're going to pull the sugar from where it could go to this. So when that crop's doing that, you're under flash drought. But what you want is during the day, if it rolls up, fine. If it just does this at night, the crop will be perfectly fine. So that's the trick, keeping those hot overnight lows. I mean, look at this. We've got overnight lows here, 73 on June 16th in Nebraska. That's too hot. But if they put water on it, they irrigate it, they can help control some of that. They have one massive advantage. Yeah.
Yeah, us here out in dryland country, yeah, we're at the mercy of Mother Nature.
Oh man. Yeah. And it just keeps getting worse the farther west you go. I'm amazed at the crops they grow there. Those guys are, I don't like bringing them to Illinois. I brought a guy here once he was from Montana, and he grew corn in Montana. And we went out and I was telling him about, we have topsoil in parts of Illinois that's like 20 feet deep. Now it's not everywhere, but like here's some of our rivers. Like he's like, where's the clay? I'm like, right where we are, the clay is like 30 feet down there. And he goes, you put a shovel in the ground in some of my fields, you're gonna hit bedrock. And he's like, where's your bedrock? I'm like, honestly, here, the bedrock might be 700 feet down. There's just a mess of stuff. Now we have bedrock closer to the surface in other spots, but it's a whole different world.
There is no doubt, no doubt. Well, Eric, you've been so kind with your time today. If you had to kind of summarize the next couple of months, obviously looking at the Pacific High, Bermuda High, anything else we need to be keeping an eye
on? I would just say the world is looking for a supply side shock to come from the United States. If you're marketing grain, I got people from Europe that bug me every day about it. I would say that there is still, it's a low probability, but there's still a potential problem in the middle of this summer that I think we can't ignore. If we see Ukraine and Western Russia slide into July heat and drought, and if any part of the central US crop starts to see that as well, I have a feeling that the market is going to be looking for a weather story mid-season. They almost always do. They're either looking for it to completely change their position or to fortify their position. That's what markets do, right? And because the market prices are, in some cases, are either at or below break even for a lot of growers right now, I would just tell people to be extremely flexible in that should you start to see weather premium built in, even if it's on a story, it doesn't have to be on reality, that you want to be just paying close attention to it. Because if the story gets told that there's going to be a problem and then it doesn't manifest itself, the bottom is deep. And I don't want anybody to get caught there. I think this is a year where the more savvy you are with the investment strategy and the marketing around your commodities, the better chances you are going to have it coming out. Excuse me. Okay. If not, boy, it's tricky.
Well, yeah, you think of where historically, corn and soybean prices will sometimes hit a summer, high based on what you just mentioned, a weather scare.
Yeah.
And
Yeah.
right as of now, the soil profile looks pretty good. So
It does. And I'll just say this, like, if you think about it, historically, when have we built in the highest weather premium based off of major summer drought problems? What time of year does it happen? When did we get, boy, what did we jump up in 20? When did we made, was it almost a $3 jump in 2012? Most of that happened June 21 to July 21. So that comes back to when I tell you that we meteorologists think we have a clue. It's at the solstice, and that's still 3 weeks away, man. So we're gonna sit here and scratch our heads until we see something definitive. And I'll just tell you this: you asked for some words of wisdom, maybe. If you ever meet a meteorologist that thinks he knows what he's talking about and gets confident, don't listen to him again. The only thing I'm confident about in weather is telling you about stuff that's already happened. I'm really good at that. Everything else is just still, man, it's tricky.
well, I know how much I enjoy watching your daily forecast. Actually, Eric, why don't you tell everybody where they can find you on a daily
Oh
basis?
yeah, sure, real easy.
Or
It's a
if you
couple
want
of
to pull,
places
hey,
you,
if
yeah,
you want to go ahead and pull it up too, I think it's really helpful. You have so many interesting tools on there for people
yeah.
to look at.
So here's a really easy one. This website I maintain. It's called Ag Weather, and it's ag-wx.com. Try to make it short and
By the way,
sweet.
I'm not going to try to get any brownie points here from you, but I have this pinned. I have the
Oh,
commodity
nice.
markets on one pin, and this is my other pin on my laptop that I go to
Yeah.
in the morning. So,
Well, there's 180,000 maps on this page, and so I like making maps. I just generate them. But you can also get forecasts. Like we were in Mason City. I was kind of showing you some of the new tools I'm building, which we hope to release at some point here. But you can come in here and generate a forecast pretty quickly and see all these things and your GDDs, your precip, your year-to-date temperatures. They're all there. And useful. Again, this is just one of the sites I've got that you can get that from. And then also on this, we do a forecast video every morning, and it goes here into this ag forecast video. Although it's taken its dear sweet time with my slow internet here. There it is. This is the one that I made this morning. But you can also just go to YouTube and find us there. I'll let you all do that on your own time. But just go to YouTube and search Nutrient Ag Solutions or search my name, and you'll be able to find it.
and also on Twitter as well.
Yeah, on Twitter. I so I'm terrible at Twitter, and the reason why I'm so bad at it is because Twitter has so many armchair quarterbacks that want to just tell you everything they think they know about the weather, and I sit here and try to navigate through them. But I follow. Oh, where's this? This is Wichita. That's Kansas flooding happening right now. Look at that.
There
You
you
talk about
go.
how saturated things are. But I always have a lot of folks on here that want to give me their information and I'm like, listen, you put your skin on the line. Let's talk about this. But yeah, Twitter's a fun spot to at least talk to folks. So yeah, there you go.
Love it. Absolutely love it. Well, everybody, Eric, I can't tell you how much I appreciate the opportunity to interview you here, and of course, the great information that you're able to share with everybody today. And thanks again. We'll have to do this again at some point soon.
Yeah,
And like I said, everybody can find Eric at Nutrient, YouTube, and Twitter, and of
yeah,
course, my end of things, Josh Mansky, of course, Farm Realtor. If you are thinking of buying or selling farmland or just want to talk farmland, give me a call, and we'll talk to you guys soon.